welcome. I'm here again to show you another one of my Perlenspiel projects that I worked on. And this is a fairly simple puzzle with 5 different level difficulties, as you probably surmised down here at the bottom. Alright, so basically, as you can tell, this is just got to navigate the puzzle and get through the maze and towards the end. There's going to be a couple obvious rules and objectives once you get started. And if you watch my last piece, it was all mouse movements and clicking. But in this game, there's no only thing you can do with clicking the actual mouse with the interface of the game is changing the level, which you can do via these. Originally, I thought of doing like a progression mechanic where if you beat the level, you progress to the next level. But I preferred to have this because it was nice and simple, and users could go back and forth. And for testing capabilities purposes, it was much easier. So basically, you start the level by moving around with the arrow keys, and you're going to hear an annoying little beep. Up at the top, you're going to see some information being tracked and dynamically updated. Move left 50 clicks, click left 0. Actually, I just lied to you. You do get to click, but you'll just see how it works. So I'm going to experiment. Oh, hey, I'm going to go to the puzzle, end and win, and then you died. Okay, so that's the annoying sound. Get up here. Now, as soon as you interact with this glyph here, this is a bead glyph that I set manually in the code, and I pick it up, and then you see updated. So now you have a click. Now you can progress. And that's basically how it works. You can see how it's going to get more difficult, and as a progression mechanic, I added new types of pickups. For example, you'll see that green pickup up there, and that actually increases your moves once you get on top of it. I started the first couple levels out easy, so players could slowly understand what the different mechanics were before I upped the difficulty. Hey, shouldn't have died again. That was a bug. And now you're going to start to see things ramp up a little bit more difficulty. The fun one about this one is you'll notice that the star actually moves to the end objective. So I thought that was pretty fun. I added in like a random variable, and every time you click this button, it's doing a dice roll, and whatever it lands on, that's what I was like, change it to this position or that position. Basically a simple XY coordinate on this bead grid. You can pretty much already guess everything here should be self-explanatory as far as the mechanics. There's a bunch of switches here you got to figure out. I don't even know if I remember how to solve this, to be honest. These are teleport switches. So you can see that it teleports your character, and then you got to figure out what combination that you need to beat it, etc. within. And you'll notice that I start limiting your clicks and your moves dramatically from the first 2 levels. So probably going to take some experimentation for users to figure it out, but there definitely is a pattern that's beatable. This one's pretty fun. Get up here, gives you some clicks, and I put these little arrows down here to kind of figure out what you might need. And you can kind of game this if you understand the mechanics and how it's happening programmatically, but that's basically how it works. These ones aren't near as intuitive as I'd like them to be, but basically the 3, it requires an X amount of clicks versus these ones requiring only 1 click. So you'll see that, and it actually decrements 3 clicks instead of 1. Puts you back here. So basically the objective of this puzzle is you need to gather a whole bunch of moves and clicks in order to get to here and win. So in the interest of brevity and time, I'm going to move on. Alright. So this one I ideally designed to be the hardest. Some of my playtesting resulted in saying that the 4th one was harder, but basically pick up your clicks, and then you can kind of teleport around. And really this one is heavy on resource management, because, let me restart it, because you start literally with only 13 moves, 0 clicks, and you get 4 clicks down here. And you can see all the green glyphs, which mean you get extra moves, but you really need to get down here, and you also need to complete some put some puzzles together in order to actually get down there. So it takes a little bit longer to solve, but that's the idea. A little bit of level progression mechanic there. So let's just jump into the code really quickly. I forgot to mention my last my last project, the toy. Here's the actual credits for the Polytechnic Institute that actually owns the Perlenspiel engine. If you're interested, you can just go to perlenspiel.org, and it has everything there. Everything you need to get started. A nice, helpful page. It's pretty handy. So here's all my global variables. I know I have a really bad habit of hard coding a lot of this stuff, and if you understand any programming, especially if you're good at arrays or object-oriented programming, this probably makes you cringe, but it's the way I like to set it up. So going in here, here's some more global variables. Especially here, these are the variables that I'm manipulating. I call these, I define these up here, and then I can call them later and adjust them. That's how I'm doing it with the glyph pickups, etc. This just clears the board. This is set around actually subtracting your moves, because when I hit I have to keybind the arrow keys to actually moving the token, redrawing it, and subtracting the last position of the token. Then there's a bunch of checks that has to make sure it's in bounds and doesn't run off the board, etc. What I've got here is I have a function for every level. So every level, when it's called, it defines how many moves, clicks, where the token position is starting, sets all the other levels to false, sets some clicks, and then it basically defines the border, the maze itself. And the way I allow those pathways is I do it via bead data, which I have it set up to where it runs a check to make sure that that data that I'm trying to move to doesn't meet a certain criteria. If it does, I can't move there. If it doesn't, or it meets a separate criteria, then it allows me to move my token there. So a whole bunch of that, because I have 5 levels and a whole ton of stuff set up for them. You can see I haven't commented out. This one is pretty lengthy. I mean, I ended up at like over 3,000 lines of code. It probably could have be done more efficiently, but I'd set it up which was easiest for me to work on it. So without getting too much detail, that's basically how all that works. I'm going to go back to that. And yeah, that about sums it up. This was just my puzzle project, which had obviously a training progression mechanic built into it to train the player the mechanics, to ramp them up in difficulty, hopefully their enjoyment as well. It is a puzzle, so technically a game that has rules and objective, and players enter it willfully. And that about sums it up. So hope you enjoy. And here we're just going to show you real quick the code that I was doing for that puzzle. As you can see, I have a ton of global variables declared up here. This project was a little more intensive than I originally planned, and this probably could have been done a little more efficiently, but this is the way I like to set it up. So you can see several things: level 1 through 5 set to false when the level loads, and it's determined by when you click on those beads at the bottom and accesses their bead data. Token, this is the position of your actual character or avatar. Bunch of stuff going on. So multiple functions. It takes extra work to actually move a token manually when you're actually arrow keying around, because you have to add the new position, subtract the old position, run checks against the boundaries to make sure you don't run off of the grid. The grid. If you do that, the Perlenspiel will throw a really annoying error because you're trying to draw something that's outside of the hard-coded grid space that's been defined. So as I was mentioning, erase token, is it in the grid? Yes. Now down here you'll see functions where I actually have like level 1, and like it defines the moves, clicks, the token, X and Y, because the whole grid is just an X and Y grid. Level 1 is true, all the other levels are false. So when you click on the button, whatever button it is, it will set the other levels to false, set that level to true, set these values, and then set everything else, which is like draws the level, the border, the bead data, etc. And I did that for 5 levels, so it goes for quite a bit. and then you go down here, and then there's all sorts of things you had to check for, because I had to create the B glyphs for increasing clicks, increasing moves, and then checking to see if if the token is actually on the winning glyph, and if you are, then you win, and then it tells you, gives you a message, etc. So that took quite a bit of setup. Here you can see what I was mentioning with the arrow right, arrow left. If you'll notice, it says PS in front of it because Perlenspiel already is coded to work with the arrow keys. You don't have to do that. So that's one. There's nice things like that built into the engine. So it's great for people that are new to programming and they want to just get down to business, to prototyping some games in a digital platform. So I'm not going to jump too much more into the code because there's like over 3,000 lines of code on this. It's pretty lengthy. I just wanted to give you a quick peek under the hood, and I hope you enjoyed that.